Assalamualaikum warahmatullahi wabarakatuh and very good evening. We are from University Technical Malaysia Melaka UTM and student of Faculty of Industrial Technology and Manufacturing Engineering. We would like to present to all of you about BMIP3563 G and Fixture Design Project. Our lecturer, Technologist Muhammad Faiz bin Wahid. Our group members consist of 4 members, which is Nur Amira binti Rozani, Afiq Wan Khalis bin Arif Azlan, Michelle Shuranipa, and Wan Muhammad Hasif bin Wan Syamsul Azri. We collaborate very closely and put significant effort to ensure the successful of this project. The manufacturing industry demand product with high dimensional accuracy, consistent quality, and shorter production time. GM fixtures are essential to that hold, support, and locate workpiece during machining, ensuring every part meets the same standard. Well-designed fixture reduce setup time and improve accuracy, minimize error, and rework. Based on Hasan Hassanin et al. 2021. First, CAD integration. CATIA V5 enable visualization, interface, checking, and design modification before fabrication. Next, 3-to-1 locating. 3 primary, 2 secondary, and 1 tertiary locating point restrict all 6 degrees of freedom. Last but not least, spring-loaded clamp allow faster loading while maintaining consistent clamping force.
For this slide is project objective. The first objective is to design a drill jig for an aluminium alloy workpiece. The drill jig is designed by applying proper locating, supporting, and clamping principle to ensure high dimension accuracy and repeatability during drilling. The second objective is to develop the component and assembly drawing using CATIA V5. This drawing provides accurate dimension and detail, making the fabrication and assembly process easier and more precise. The third objective is to fabricate, assemble, and evaluate the drill jig. After manufacturing, the jig is tested to ensure that it functions properly and produce accurate drilling result. The next slide is locating system. Our design follow the 3-to-1 locating principle, which is a standard method for accurately positioning a workpiece. 3 locating pins are placed on the primary surface, 2 on the secondary surface, and 1 in the tertiary surface. Together, these 6 points restrict all 6 degrees of freedom in the workpiece. In our design, the bottom surface acts as the primary datum, while the side locating surface and end stop prevent any unwanted movement during machining. This ensures the workpiece remains stable, improve machining accuracy, and produce consistent drilling result.
This slide explains the supporting system and clamping system used in our fixture. The supporting system consists of the base plate and guide slots. The base plate provides a rigid and stable platform that supports all fixture components and resists machining force. The guide slots allow the slider to move smoothly during loading and unloading while maintaining proper alignment. For the clamping system, we use 2 clamps to apply downward force on the workpiece. This keeps the workpiece firmly against the locating surface and prevents movement or vibration during machining. The spring mechanism also helps with faster loading and unloading while maintaining a consistent clamping force. As a result, the fixture improves machining stability, accuracy, and overall product quality. Next, I will explain the initial 2 design of our jig and fixture. This slide shows the fixture from our different views, which are the top view, front view, back view, and side view. Starting with the top view, it shows the overall arrangement of the fixture components. We can clearly see the base plate, slider, workpiece, stopper, clamps, and fasteners. The slider moves along the guide slots on the base plate, allowing the workpiece to be loaded and positioned easily. The front view shows the height relationship between the components. It also illustrates how the workpiece is clamped using 2 clamps, while the base plate provides a stable foundation during machining. Next, the back view shows the symmetrical arrangement of swing clamps. It also highlights the adjustable locating pin, which is used to fine-tune the position of the workpiece for better accuracy. Lastly, the side view illustrates the working principle of the fixtures. The workpiece is first positioned against the stopper using the locating pin, and then the clamps apply downward pressure to securely hold it during machining. The isometric view helps us visualize how all the components are assembled together. The main components include the base plate, which acts as the main support, the slider, which moves along the guide slots, the stopper, which locates the workpiece, the locating pin, and adjustable locating pin, which ensure accurate positioning, and the clamps, which securely hold the workpiece during machining. The key dimensions of the fixtures are also listed. The base plate measures 298 by 148 millimeters. The slider is 157.4 by 101 by 44.7 millimeters, and the stopper measures 90.6 by 39.3 by 37.2 millimeters. Lastly, the fixture is designed with a general tolerance of plus minus 0.1 millimeters, a locating pin tolerance of plus minus 0.05 millimeters, and a surface finish of roughness average with 3.2 micrometers. The base plate is made from mild steel, while the slider and stopper are made from aluminium alloy, providing a good balance between strength and weight.
Assalamualaikum, my name is Nur Amira. Next, I will present the final tooth drawing and BOM, Bill of Material. The final tooth drawing was developed by using Kata V5 after the feature design had been finalized. The assembly drawing were used to verify that every component fit correctly before fabrication. It is also served the main engineering reference for manufacturing, assembly, and dimensional inspection of the feature. The final assembly consists of several components, including the stainless steel base plate, aluminium fixture body, slider, stopper, adjustable locating pin, swing clamp, M10 bolt, nuts, washer, and the aluminium workpiece. The component perform a specific function to accurately locate, support, and clamp the material during machining. The base plate was manufactured by laser cutting because it provides high dimensional accuracy and a rigid foundation for the fixture. The fixture body, slider, and stopper were manufactured from aluminium because aluminium is lightweight and easy to machine. The M10 bolt were custom fabricated using a conventional lathe machine, followed by external thread cutting to produce the required thread. Okay, now let's move to the Bill of Material or BOM. The BOM lists all components required to fabricate and assemble the fixture. It includes the name part, material, quantity, and remarks, making the fabrication and assembly process more systematic. Our BOM consists of 13 components. The custom fabricate part include the workpiece, fixture body, slider, stopper, adjustable locating pin, swing clamp head, and M10 bolts. Meanwhile, the base plate and swing clamp head were produced by using laser cutting. Um, and for M10 bolt were fabricated using the lathe turning followed by external cutting. Standard components such as the M10 nuts, M10 washer, diameter 8 nuts, washer diameter 8 were used to simplify assembly and future maintenance. Okay, next is fabrication, assembly, and discussion. For this fabrication stage, we selected different manufacturing process according to the function and geometry of each component. First, the stainless steel base plate and swing clamp head were produced using laser cutting. This process was selected because it provides high cutting accuracy, produce complex profile, and minimize material waste. The next one is the fixture body, slider, and stopper were machined by using conventional milling machine. Face milling was first carried out to obtain flat reference surface, followed by pocket milling to produce the workpiece cavity. Drill operation use diameter 8 and diameter 10 drill bits were then performed to produce the locating and fastening hole required for assembly. The M10 bolts were manufactured using a conventional lathe machine. The bolts were first turned to the required diameter and length, followed by external thread cutting to produce the threaded profile for secure fastening during assembly. The adjustable locating pin and locating pin were also fabricated before installation into the fixture. After all machining operation were completed, every component was deburred, cleansed, and inspected. The fixture was then assembled by install the fixture body, slider, stopper, locator pin, swing clamp head, bolts, nuts, and washer onto the stainless steel base plate. Finally, the completed fixture was inspected to ensure all components were correctly aligned and function properly. During the fabrication, our group encountered several challenges. One challenge was maintaining dimensional accuracy between mating components, especially the slider mechanism, which requires several fitting trials to achieve smooth movement. Another challenge was producing accurate external thread on the M10 bolts, as careful setup and repeated measurement were necessary to obtain the correct fit with the nuts. In addition, laser cut component required deburring and minor finishing before assembly because small burrs are along the cut edge. Despite these challenges, the completed fixture successfully meet the design objective. It is also able to accurately locate, support, and securely clamp the aluminum workpiece during machining, demonstrating that the design is suitable for face milling and drill operation.
To conclude this presentation, this project successfully achieved its objective of designing and fabricating a machining fixture capable of accurately locating, supporting, and clamping a workpiece. The fixture was developed in CATIA B5 and manufactured using turning, milling, and CO2 laser cutting. Functional design, the manually operated clamping mechanism using threaded pins, clamp heads, nuts, and washers. It provides sufficient holding force with simple manufacturing and easy maintenance. Next, for standard fastener, we use M8, M10, and M12 bolts with matching nuts and washers to ensure rigidity and simplified assembly and future maintenance. Last but not least, overcoming fabrication challenge, which is dimensionally inaccuracies, fitting issues, threading difficulties. It improves understanding of manufacturing limitation and the importance of precision and quality control. The complete fixture demonstrates that proper fixture design is essential for achieving machining accuracy and production efficiency. That's all from us. Thank you. And we hope you guys can enjoy the functional video that we include in next slides and enjoy. Thank you.